On the most basic level, there are two major categories to consider when evaluating a camera image: the brightness and color. Exposure or shading refers to the brightness of an image, and if it's off, we speak about it in terms of under or overexposure. The distribution of light and dark, the contrast of an image, can also fall into this category. Color or painting of the image refers to everything else: white balance, black balance, tint, hue, and saturation. Let's begin with exposure, and we'll discuss color in a separate lesson. In every camera, exposure is impacted by the following three variables: iris, shutter, and sensitivity, which gives us the exposure equation. Iris plus shutter plus sensitivity equals exposure, measured in stops of light. Iris, or aperture, determines how much light we're letting in the lens of the camera by setting the f-stop of the lens. Shutter determines the length of time that light is being allowed to expose the sensor, set in time or measured in degrees. Sensitivity determines how sensitive the sensor within the camera is to light that reaches it. This is set in terms of ISO or gain. Let in too much light or have the ISO too high and the image is overexposed. Exclude too much light or set the ISO too low and the image will be underexposed. So, first, what is a stop of light? A stop of light represents a doubling or halving the amount of light with respect to your image. One stop overexposure is twice as bright as proper exposure, and one stop underexposure is half as bright as proper exposure. 2 stops over doubles or halves again, making things 4 times brighter or darker, and 3 stops doubles or halves yet again, 2 times 2 times 2, making it 8 times brighter or darker than the original. Most cameras allow adjustments of parameters in increments of 1/3 of a stop at a time. Broadcast lenses and some cine lenses have irises that are smoothly adjustable without any clicks or noticeable increments. Going back to the exposure equation, let's plug in some numbers and assume this combination gives us a properly exposed image, which is to say it has an exposure value of 0. f4 plus 1/60th of a second at ISO 400 equals 0. Doubling the ISO, turning up the sensitivity of the sensor from 400 to 800, will increase the exposure by 1 stop. Halving the ISO, turning down the sensitivity of the sensor from 400 to 200, will decrease the exposure by 1 stop. Lengthening the shutter speed, or doubling the exposure time, from 1/60th of a second to 1/30th of a second, will increase the exposure by 1 stop. Shortening the shutter speed, or halving the exposure time, from 1/60th of a second to 120th of a second, will decrease the exposure by 1 stop. Opening the lens from f4 to f2.8 to double the amount of light coming in will increase the exposure by 1 stop, and closing the aperture from f4 to f5.6 to halve the amount of light coming in will decrease the exposure by 1 stop. And changing any of these in combination can work together to keep the exposure neutral. For example, opening the lens from f4 to 2.8 will increase the exposure by 1 stop, while also halving the ISO from 400 to 200 will decrease the exposure by 1 stop, giving a net exposure adjustment of 0. Similarly, closing down the lens from f4 to 5.6 to decrease the exposure by 1 stop, while also doubling the ISO from 400 to 800 will increase the exposure by 1 stop, giving a net exposure adjustment of 0. Now that we know how stops and the basic exposure equation work, we can move on to applying this knowledge to live production.